The relation could be something specific like x is equal to the square root of every y, or y is equal to 3x plus 4, okay? But there's the relations. Now, relations can be represented in various forms. As you see right here, we can use a mapping, an ordered pair, an x and y value to represent the relation. We can represent the relation using a graph, or we can represent a relation using this diagram right here. This diagram right here is referred to as a mapping, where the mapping matches the domain to the range, values in the range. So like right here, the relation here is that -2 is going to be operating. We're going to do something in -2 where it's going to be mapped to 0. So the relation is that -2 gives us a y value of 0, or an output value of 0. The same thing with 6. That gives us an output value of 1. 9 gives us an output value of -5. So this is an example of a relation. Now, what is the domain and the range? Well, your domain of any relation is the x coordinates in that relation, is the first element, whether the relation is represented in a graph, an ordered pair, or a mapping. It's always going to be the first element, again, of that relation. So with an x coordinates, x and y coordinates is the x coordinates and the y coordinates, okay? So that's your domain. And your range is going to be the set of y coordinates in the relation, the second element, again, of that relation. Whether they're numbers or letters or whatever it is, it's always going to be that second value of that relation. Okay, so let's look at some examples of this. Let's look at some ordered pairs, and let's see what the domain and range is. Let's make a little correction here. There should be a comma, not a period. So here we have a relation, and we have 4 elements in the relation. We have, again, this, and this right there, okay? So the domain here is going to be the first element of each ordered pair, okay? So let me undo that one. I'm going to get a highlighter. Here we go. So that would be these numbers right here. These numbers are going to be the domain of this relation. So our domain is going to be the list of -1, 7, 3, and -5. Now in mathematics, anytime that we make a list of elements, whether they're numbers or variables or, again, anything else, we use these brackets, these squiggly parentheses, again, which are called braces, these braces, in order to identify that we have a list of elements. Now the range for this set is going to be the second element of the ordered pair. So here it will be 1, 4, 0, and -1. So let's see how well you understood this. Pause the video and identify what your domain and range is for this second relation here. So let's see, let's check your work. So the domain for this is going to be the list of -2, -1, 0, 1, and 4. And the range would be 4, 1, 0, the number 1 again, which is already on the list, and the number 4, which is also already on the list. So we'll just leave it like this. So this is going to be your range. Now you can write the numbers again because 1 and 4 are being repeated. You don't have to write it again the second time, but if you do, that's fine. It'll be marked correct regardless. But here, these are the elements, again, in the range. And whenever an element repeats, it's not necessary to copy it down a second time. Again, it's already in the list. So there you go. Okay, now a relation can fall into one of 2 categories. The relation can be discrete, where a set of specific values that cannot be divided any further. So for example, like the number of oranges, the number of apples, the number of tennis shoes, the number of people, the number of desks, again, in a classroom, going to be, again, the specific value, okay, a whole number value that cannot be broken up into fraction values. Okay, that is referred to as discrete data. Data that can be broken up, like, for example, time, or a measurement, again, like the measurement of how long a room is, the length, the width of an object, again, that's considered as continuous data. It can be broken up within a smaller set of values, so values in between whole numbers. Okay, we can have half of a minute, which is, again, going to be like seconds. We can have half of a second as well. So again, it can be broken into smaller intervals and smaller sections. That is referred to as continuous data. And the way that we identify the domain and range for a discrete set of data is different than the way we identify the domain and range for a continuous set of data. So let's look at an example of how we get the domain and range for a discrete set of data of a relation of discrete data. So here we have a relation which is represented by discrete data, these 5 points here. And the way we're going to determine the domain and the range is by identifying, again, here we go, is by identifying what the ordered pair is, so identifying the x and the y values. So like right here, this ordered pair, this one right here, the x and y value is -8, -4. The second ordered pair is -1, -2. The one in the middle has an ordered pair of 0, -2, 4, -1, and then the last one is 8, 0. So for a discrete set of data points, we just simply have to identify what the x and the y value is for each data point. And then our domain, again, is simply going to be, just like the last example, is going to be the set of x and y values. The first element is the domain, the x's, and the range is going to be the y value. So here our domain is going to be the list of -8, -4, 0, 4, and 8. And the range is the second element, again, of this relation, which is -4, -2. I'm sorry, that's -3. This one right here is -3. -2, 1, and 0. So that's how you identify, again, the domain and the range for relation for discrete data. Now, if the relation is represented by a graph of using, again, continuous data, where we're looking at everything in between, not just those points, not just -8, 0, -4, -3, 0, -2, 4, -1, and 8, 0. We're looking for everything in between as well. Well, the way we get the domain for this is that we have to include everything, again, in between those points as well. So it's not just going to be these points that's going to be part of the domain and range, but it's going to be everything in between as well. So all of the x and y values in between those 2 points, all of the x and y values between those 2 points, and so on. So the way, in order to list this, because it's going to be obviously not possible to list all of those numbers between -8 and +8, because there's an infinite number of values in between this endpoint here and this endpoint here, is that we use what's called interval notation. So the domain for this relation will be represented by intervals. And the way we do this is that we look at the farthest left that the graph is going to reach, which the x value here is -8, and the farthest the graph is going to reach has an x value of +8. So the domain is said to exist for all x values between -8 and +8. And in interval notation, we used, again, either brackets and parentheses, which we'll get into more detail in a second. And we say that the domain is going to be all of the values between -8 to +8. And we use a comma, again, to indicate this. So we say from -8, comma, to +8. Now we use, again, this bracket right here because we're looking at closed circles, but we'll get into more details right there in the next example, the next page. Now for the range, the same thing. For discrete data sets, since we're considering, again, all of the points, not just the whole points, but all of the points, all this, even the sections in yellow, we have to look at what's the lowest to the highest that the graph reaches. So the lowest the graph reaches is -4 for y, and the highest that the graph reaches is the x-axis, which is y is equal to 0. This right here is 0. Since this is -1, -2, -3, +1, +2, +3, 4, 5, and so on. So this one right here in the middle is going to be 0. So the range for this function is going to be all of the y values from -4 to 0. And we use again parentheses. So this here, like I said, is an example of a continuous relation, and this right here is an example of a discrete data of a relation. And notice again the difference. One of them again does not connect the dots from the left to right or up and down, and this second one does. So we have to consider all of the points. So the way we calculate, or the way we determine the range and the domain and range for this, is going to be different depending if it's a relation. We just simply list the numbers, but for continuous data, we have to consider everything in between. Now, because of that, it falls into one of the followings when we have, again, a relation using a graph with endpoints. So let's go over how to identify the domain and range from a graph with endpoints. Now, since we're going to be using interval notation to represent, again, this idea, we have to talk about when we have, again, a closed interval, and when we're going to use square brackets, which is this symbol right here, or parentheses, which are these symbols right there. We use their square brackets to indicate that the endpoints are included in the interval. Which means, again, we have closed circles as endpoints. We use our parentheses to indicate that the endpoints are not included in the interval, and that is represented by using open circles on the endpoints. So let's look at the first example right here. This is an example that is considered where we're going to have a closed interval because the two endpoints are both closed. As you see right here in the diagram, this endpoint and this endpoint is closed. So this is an example of a closed interval. So if we look at our domain, let's say this is an x1 value, this is an x2 value. The way we identify the domain here is that we look at the left point, which is x1. We don't know what the x value is, we'll just call it x1. And the right endpoint, which we'll just simply call it x2, because again, this is going to be have an x2 y value, and it's going to have another x and y value. We're going to look at how far to the left and how far to the right the graph is going to exist. So here, the way we identify the domain for this type of example is that we make an interval of x1 to x2, and because both endpoints are closed, we use a square bracket to indicate that we have a closed interval. And the same thing with the range. The only difference is that for the range, we go from bottom up. So for domain, we go from left to right, and for range, we go bottom up. So this would be y1, this would be y2. So our range would be all of the y values between y1 and y2. And because, again, the two endpoints are closed, we use a square brackets to indicate that. Now, a half interval uses a square bracket on one endpoint and a parenthesis on the other endpoint because, again, we have an open and closed circle on those endpoints. So let's start with the domain. So for our domain here, if I say that this is my x1 and I say that this is my x2, my domain would be all of the x values, because it's continuous, it would be all of the x values from x1 to x2. Now, because x1 has an open circle, this is open, that means that x1 is not included in the domain, so we use a parenthesis to indicate that. And x2, because x2 is closed, that means that one is included, so we use a square bracket to indicate that. So, and this is referred to again as a half interval, and it makes sense because again, half of the interval is open and the other half is closed, so that's why this is referred to as a half interval. Now our range, let's look at our range. Let's call the one on the bottom y1, and we'll call the one on top y2. The range for this relation would again start with y1 and go to y2. So from y1 to y2. So the lower number, the smaller number always, or in this case, the lower number goes first and the upper number goes second. Okay, so you start by listing the numbers in that order. Now, because on y1, the endpoint on y1 is closed, y1 is included in the interval, so we indicate that we're using a square bracket, and because on y2 it's open, we use a parenthesis to indicate that. Parenthesis to indicate that. And that would be a half interval. So you see, half of it is open, the other half is closed. Or in this case, closed and then open. And finally, the last example is an open interval. An open interval uses parentheses on both endpoints because both endpoints are open. So as you see here we have an open endpoint, and here we have another open endpoint. So for the domain here, x1 to x2 will be open, and the range, the same thing. y1 to y2 will also be open. So this would have to be my x1 to x2. And for range, the same thing. y1 to y2. All right, so let's look at some examples of this. Let's look at some actual relations, and let's determine the domain and range of each relation. So for example, problem number 5, so example 5, exercise 5, let's look at what the domain is going to be. So to identify the domain, we're going to look at how far to the left and how far to the right the graph reaches. Sometimes it's easy just to simply look at the endpoint. So here we have an endpoint and we have another endpoint right there. But we always want to look at how far to the left and how far to the right the graph reaches. So to the very far left and the very far right, the graph reaches -3. This is -2. This would be -3 to +3. -3. Okay, so this is the farthest to the left and the farthest to the right the graph is going to reach. So the domain, we start and say that domain is from -3 to +3. So start by first indicating again where the endpoints are of the relation. What's the farthest to the right and farthest to the left, and to the farthest right that the graph again, or the relation, extends. So those are going to go from negative to +3. Now, at those endpoints, we now want to look at if it's going to be open or closed. Well, the one on the very far left, we're using again this endpoint right there. And because that one is closed, we're including -3 as part of the domain. So we use a bracket to indicate that. And because it's open over here, this endpoint is open, we're going to use a parentheses to indicate that +3 is not included. So the domain for this relation would be all of the values from -3 to +3, including -3, but not including +3. Now for our range, we do the same thing. We look for the lowest value that the graph is going to reach. Sometimes, again, it looks like it stops right here, but if we look at the whole graph, we have to look at the whole graph. It doesn't stop there. It goes even lower, because to the left of that, you see that there's more pieces of the graph that go beyond and go lower than that. So the lowest point that the graph reaches is this point right there, which is at negative 9. So that's the lowest point that the graph reaches, negative 9. And the highest point that the graph reaches is not this point right here, because if you look to the right, there's points or parts of the graph that are higher than that. And the highest that the graph reaches is this point here, which is at positive 9. So the range is going to be all of the y values from negative 9 to positive 9. So we start by first writing the numbers again in that order from down to up, and then we look at the endpoints to determine if it's going to be an open or closed. So because the circle is closed, we have a closed circle here that's going to use a square bracket, and because we have an open circle up here, that's going to use a parentheses. So this is going to be half interval as well. Let's look at another example. Let's look at example number 6. So let's see, you try this example yourself. So pause the video and determine what the domain and range is, and then come back and check if your answer is correct. So let's see, let's go now and check your answer. So for the domain, you know what, let me color coordinate this and let's do this in blue. So for the domain, we're going to look at how the farthest left that the graph extends, and it extends all the way to negative 3, and the farthest to the right that it extends, and it also extends to positive 3. So this graph extends and exists between those two vertical lines. So the domain here is all of the x values from negative to positive 3. And just now that we have the numbers in order, the left endpoint is open because of the open circle, so we use parentheses there, and the right endpoint is closed, so brackets on that one. Now let's look at the range. For the range, we look at the lowest that the graph extends. So the graph extends no lower than this point right here, which is at negative 7. And it goes higher than this endpoint. This endpoint right here is not the highest that the graph reaches. Notice that there's points higher than that. And the highest that the graph reaches is this up here at positive 5. So our range is going to be all of the y values from negative 7 to positive 5. Now let's determine again if we're going to have open or closed endpoints. Well, at negative 7, the endpoint is obviously this one right here, which is opened, so that's going to use a parentheses. Now at positive 5, it's not this endpoint. We're not looking at this endpoint right here. We're looking again at this point up here, which is this one right here. So we're looking at this point right there. And because this point is not open, is not open, it's closed because it's not indicated with an open circle. We have to assume again that this is a closed dot right there. So that means it's going to be included. So this endpoint right there is closed, which means that that's represented again with a bracket. So another half interval for this example right there. And let's see, let's look at one more example of this. Domain and range. So let's see. Pause the video and then come back and check your answer. Okay, let's see. Let's check your answer. Let's see what you got. So for the domain, again, this extends no further than negative 3 and positive 3. So it looks like all the examples I've given you are just examples of things that go from negative 3 to positive 3. Now, because the endpoint, again, the farthest that it reaches has open circles to those endpoints there, we're going to use parentheses to indicate that. Now, let's look at the range. The range, the lowest that the graph reaches are these two endpoints down there, which are both open, which is at -9. And then this position right here, which is at 0. This is y is equal to 0. This is y is equal to -9. So the range is going to be all of the values from -9 all the way up to 0. Now at -9, both endpoints are open. As you see right here, let me erase these points right there. You see right there, they're both open. So we're going to use a parentheses to indicate that we have an open endpoint at -9. And at 0, again, we're looking up here. We're looking at this point right there. And because this is not open, then it's assumed, again, safely assumed that's it's closed. So we have a closed endpoint up there. So that's going to be a bracket. So the range for this is going to be from -9 to 0. Okay. Now let's look at identifying the domain and range of a relation from a graph with arrows as endpoints. So instead of having endpoints, let's say we have arrows instead. Well, arrows are always used with parentheses, and we're always going to use parentheses with the following two values, with -infinity or +infinity, because that's what the arrows are pointing at. They're going to be pointing at one of the infinities. They're pointing towards the infinities because they continue moving in an upward direction, a downward direction, a direction to the left, or a direction to the right. So those are going to always be using going towards the infinities. And we use, again, parentheses in any situation where we're using for the domain and range of approaching negative or starting at -infinity and finishing at +infinity. So let's look at this example right here. In this example right here, notice that the two endpoints are arrows. So this thing does not have an extension. It has no infinite extension. It continues, I'm sorry, it has an infinite extension. It continues moving to the left. -4 is not the farthest to the left that this graph reaches. It's going to continue moving further and further to the left until we get to -infinity. And the same thing with the arrow on the right. This arrow right here on the right is not going to stop right here at -8. It's not going to stop right here at -8. It's going to continue moving to the right all the way to +infinity. So for this example right here, the domain is going to go all the way to -infinity, all to +infinity, because it has no endpoints. It extends beyond the graph, what we see right here, and it goes on and continue moving to the far left and far right until it reaches, again, the respective infinities, again, on the x-axis. And because, again, as of the arrows, we always use parentheses to indicate that, because we don't actually approach, we cannot include those values, because, again, it always gets smaller and smaller every single time. Infinity, again, there's always a number, again, exceeding beyond infinity every single time. And the same thing for the range. For the range, well, this is not going to be the lowest that the graph reaches. It's not going to reach a lowest of -10. The arrow indicates that it's going to go lower to -11, then -12, then -14, and so on and so on. So the farthest that the graph is going to reach down is going to be -infinity as well. And the farthest, the highest point that the graph is going to reach is not going to be +10. The arrow indicates that it's going to continue moving up. So it's going to go to 11, then 12, then 13, 14, and so on. And it's going to continue increasing. So that means it's going to approach and eventually reach +infinity. And we always essentially, again, just a very simple rule of thumb is that we always use parentheses to indicate, again, that we're approaching the infinities. So -infinity, +infinity would be the range. And we close this, or I'm sorry, we use brackets to indicate, again, parentheses, not brackets, parentheses to indicate the range when we're using infinity, whether positive or negative, and at the very beginning or at the right. And notice, again, the order. -infinity always goes before +infinity, okay? Always has to be in that order every single time. Now let's say that we only have an arrow on one end, okay? Well, for one of them. For right here, for the domain and the range, it's going to be different. For the domain, for this graph right here, well, the graph is not going to stop at this place right here, and it's not going to stop at -4 or at -3, okay? It goes beyond -3 to +3, and it doesn't stop at -4 to +4, and does not stop even there. It keeps on moving wider and wider to the left. So because of the arrows, this is going to continue moving this direction. So that means it's going to move all the way to -infinity. And because of this arrow, this graph is going to become wider and wider and wider. And it's going to go all the way beyond 10, all the way to +infinity. So here, our domain, is from negative to +infinity. Now the range, however, is different because this one does have a low point. The lowest that the graph is going to reach is this y value of 0. It doesn't go any lower than that. So the range here, starts at 0. 0 is the lowest point that it's going to reach. And the highest point it's going to reach is not going to be 10. Because of the arrows, just like the previous example, is going to continue getting higher and higher and higher. And it's going to continue moving higher without any bound, without stopping. So that means it's going to approach +infinity. So the range for this, in terms of what the numbers are, is goes from 0 to +infinity. Well, with the infinity, we know that we always have to use parentheses to the infinity. So this end is going to have a parentheses on it. However, at the 0, because it is not open, it's closed, because of the closed dots again right there, that's going to use a bracket for that example. So we'll use a closed symbol, a bracket, a square bracket, to indicate that we have a closed circle endpoint on that end there. So the range is going to be all of the values from 0 to infinity, including the number 0 as well. Let's see, you try this example right here. So pause the video and try this example. Okay, let's check your work now. And let's look at this example right here, where we have, again, a starting point and an arrow on one end. So for the domain, let's look at how far to the left it reaches. So the farthest left that the graph reaches is -4. It does not go beyond that endpoint right there. So we say that the domain starts at -4. Well, what's the farthest to the right it's going to reach? Well, because of this arrow right here, we know we don't stop at +10. It continues moving to the right and increasing. So that's going to approach +infinity. Okay. Now, because at -4 we have an open circle, we have to use parentheses to indicate that. So we're going to have an open parentheses of -4 to infinity. Now let's look for the range. Well, the range of this thing, we'll now look at the lowest to highest, the vertical distance. So the lowest that the graph reaches is that endpoint right there, that open circle, which is at the y value of 0. It's on the x-axis, which is y equals to 0. So the lowest y value is going to be 0. And well, what's the highest y value? Well, it's not going to be 4, okay? 4 is not the highest y value because it's going to go further than that because of the arrow. I know it's pointing to the right, but it's also increasing. The graph is also moving upwards. So the graph is getting higher and higher and higher. And it has no highest point. It's going to continue getting higher and higher every single time. So that means it's going to go beyond that, and it's going to go infinitely increase. So our range is going to be all of the y values from 0 all the way to infinity. Now, with infinity, obviously, we use a parentheses to indicate that. Okay, it's never going to be closed on the infinity. But on the 0, because of the open circle, that's going to use, again, parentheses as well. So our range here is also going to be an open interval from 0 to infinity. And there you have it, class. This is the last example on relations and how to identify the domain and the range of relations using graphs, with arrows, using graphs with endpoints and using the graph of a discrete data set. So it's different, okay? It's different. In order for discrete, we just simply list the numbers, but for continuous data, we have to look at all the numbers in between. So we start at a starting point to an ending point, so starting and ending point, and see again all, and that notation again will indicate all of the numbers in between as well. Now the key thing is understanding again when we use parentheses and when we use brackets when we're using this interval notation to identify the domain and the range. So there you have it. All right, well, thank you again for watching. Let me move over here. Thank you again for watching. If you have any questions, please send me a message through email. And like always, I hope you have a great day. And well, I hope you have a great day. Goodbye.